So today we are going to discuss about mechanism of enzyme action. So as I told you yesterday, two theories have been put forth. One is known as lock and key theory, and another is known as induced fit theory. Induced fit theory. So first we will discuss lock and key theory. Lock and key theory. So this lock and key theory, it was proposed by Emil Fischer. It was proposed by Emil Fischer in 1894. This lock and key theory, it is also known as a rigid catalytic site theory. It is also known as rigid catalytic site theory. So according to this theory, every enzyme has got a part where substrate binds to it. So that part of an enzyme, suppose this is an enzyme, it has got a part. This is the enzyme. This enzyme has got a part where substrate binds to it. So this part of enzyme where substrate binds to it, this is known as active site. It is known as active site of an enzyme. Or we also call it as substrate binding site. Substrate binding site. So every enzyme has got a part where substrate can bind to it. So that part of an enzyme where substrate can join to it, that is known as active site or substrate binding site. According to this lock and key theory, this site of every enzyme is having a fixed shape. That is why we call it as a rigid catalytic site theory. This active site, it is also known as catalytic site. It is also known as catalytic site. So according to this lock and key theory, this part of the enzyme where substrate can bind to it is known as active site, substrate binding site, or catalytic site. So according to lock and key theory, this site of enzyme, active site of enzyme, it is having a fixed, it is having a rigid, or fixed shape. Fixed shape. So according to lock and key theory, the active site or substrate binding site or catalytic site of an enzyme is having a rigid or fixed shape. And only a substrate whose shape perfectly coincides with the shape of active site can bind to it. Only a substrate whose shape perfectly coincides with the shape of active site, active site can bind to it. So according to lock and key theory, every enzyme has got a part where substrate binds to it. So that part of enzyme where substrate can bind to it is known as active site, or it is known as substrate binding site, or it is known as catalytic site. So according to lock and key theory, only a substrate whose shape perfectly coincides with the shape of active site. So the shape of substrate must be perfectly matching with the shape of active site. That can only bind to it. So active site is fixed. It has got a fixed or rigid shape. That is why we also call it as rigid catalytic site theory. So Emil Fischer gives stress upon the point that the active site of an enzyme has got a fixed or rigid shape which does not change, and for a substrate to bind to it, the substrate must perfectly have the shape matching with the active site of the enzyme, right? So for that reason, we call it as a rigid catalytic site theory, or we call it as a lock and key theory. Why we call it as lock and key theory? You know, every lock is only opened by its specific key. Nowadays, there are locks available in the market which can be opened by any key. But those locks which are of standard companies, for example, you have got link locks. A link lock can be only opened by its specific key. The key of another lock cannot open another lock, right? So as a lock is only opened by a specific key. Similarly, a substrate whose shape perfectly matches with the shape of active site of enzyme can join to it. And then enzyme can convert that substrate into a product, right? So that is why it is known as a lock and key theory. So we have got a lock. Suppose this is our lock. It has got a keyhole here, right? So this lock can be opened only by a specific key. It can only be opened by a specific key, right? So when the lock and key join together, this is the key in the lock, the keyhole. Then this lock can be unlocked. Then only this lock can be unlocked, right? By a specific key. So here the key is substrate. Sorry. Here the key is the enzyme and lock is the substrate because substrate is to be catalyzed. Substrate is to be catalyzed. A substrate is to be broken into product or a substrate is combined to form a product, right? So there are two types of enzymes. Anabolic enzymes, they are involved in formation of new compounds. Catabolic enzymes, they are involved in breakdown of compounds, right? So as a specific lock can be only opened by a specific key, similarly, a specific substrate whose shape perfectly coincides with the shape of the active site of the enzyme can be catalyzed by this enzyme. So that is why we give it the name lock and key theory. And in this theory, Emil Fischer stresses upon that. The shape of the substrate must be perfectly coinciding with the shape of the active site of the enzyme. If the shape of substrate does not match with the shape of active site of the enzyme, then the substrate cannot join to it. So for that reason, we call it as rigid catalytic site theory. So according to Emil Fischer, this catalytic site of enzyme, it is rigid, it is having a fixed shape, it cannot be changed. For that reason, we call it as rigid catalytic site theory. And for a substrate to bind to it, the shape of the substrate must be perfectly matching with the shape of active site of the enzyme, right? So when a substrate binds to this enzyme, the enzyme carries out catalysis. Now this is the enzyme and this is a substrate whose shape perfectly matches with the active site of the enzyme, right? Now they will combine. This is enzyme, this is substrate. They will combine, they will form enzyme substrate complex. This is enzyme, this is substrate. And they form enzyme substrate complex. They form enzyme substrate complex. Then this enzyme, it carries out the catalysis of the substrate. And finally, it breaks the substrate into its products. This is one product, this is another product. So these two are the products. And enzyme itself remains unaltered at the end of the reaction. So this is enzyme and these are the products, right? So according to lock and key theory, the active site of an enzyme has got a fixed shape. For a substrate to bind to it, the shape of the substrate must be perfectly coinciding with the shape of the active site of the enzyme. When they have the shape is coinciding, then the substrate binds to enzyme and it forms enzyme substrate complex. Then enzyme carries out the catalysis, and enzyme converts the substrate into its products, and at the end of the reaction, enzyme itself remains unaltered. Why we call it as rigid catalytic site theory? Because according to Emil Fischer, this catalytic site of this active site of enzyme, it has got a rigid fixed shape. The shape of active site does not change. That is why it is known as rigid catalytic site theory. However, this theory was modified by another scientist in 1958, and he gave a different theory known as induced fit theory, or we call that as flexible catalytic site. There was another scientist then known as Koshland in 1858. He proposed a new theory known as induced fit theory. Induced fit theory, or we call it as flexible catalytic site theory. So Koshland thought that the active site of an enzyme is not rigid, it is not fixed. Emil Fischer thought that the shape of active site was rigid and fixed. But Daniel Koshland, he thought that the shape of the active site is not rigid, it is flexible. So that if a substrate does not perfectly coincide with the shape of the active site may be slightly modified so that substrate can perfectly bind to it. Suppose this is the substrate. Now, we have got a substrate of this shape. So the shape of substrate is slightly different from the shape of active site of the enzyme. So what will happen? This enzyme, it will modify its active site. It will modify the shape of its active site so that the substrate can bind to it and catalysis is carried out. So this is the enzyme, this is the substrate. You can see in the diagram, I have drawn the substrate slightly different from the shape of the active site of the enzyme. Now this enzyme, it changes its shape of active site. It modifies the shape of its active site so that substrate can perfectly bind to it. Then catalysis is carried out and the substrate is changed into products. And at the end, enzyme itself remains unaltered and the shape of its active site is again resumed to its normal shape. So now what is the difference between two theories? Emil Fischer thought active site's shape is fixed. It is rigid. It does not change. A substrate must be perfectly matching with the shape of the active site for the catalysis. But Daniel Koshland, he said that, no, this is not true. A substrate may slightly vary from the shape of active site of the enzyme. This is the shape of active site of the enzyme. If we look at the substrate, its shape does not perfectly resemble with the shape of active site of the enzyme. So he said that the active site is flexible. Active site is flexible. The catalytic site is flexible. So it gets modified so that this substrate, which is not perfectly matching to the shape of the active site, it can bind to it. So this active site is slightly modified, it is changed so that substrate can bind to it. Then catalysis is carried out and a product is formed, right? And at the end, enzyme is released. And then this enzyme resumes its original form, right? So this is known as flexible catalytic site. So the two theories differ from each other on the basis of the shape of the active site. So in the first theory, it was considered that the active site of an enzyme is rigid and it is not flexible. In the second theory, it is now considered that the active site is not rigid but it is flexible. If the substrate does not perfectly coincide with the shape of active site, then this active site gets slightly modified so that substrate can bind to it. Then catalysis is carried out, products are formed, and after the product formation, then enzyme resumes its original shape. So these are the two theories which were put forth to explain the mechanism of enzyme action. So when the substrate binds to the enzyme, what happens? So for the substrate to bind to the active site, it forms some temporary bonds with the amino acids of the active site. So formation of these temporary bonds between substrate and enzyme at the active site, it brings the product, it brings the substrate into transition state. So when the substrate is brought into transition state, that helps the substrate to get easily converted into its product. So temporary bond formation between substrate and the active site of the enzyme brings the substrate into transition state, which favors its easy conversion into product. So that is the role of enzyme. So enzyme, they just lower the activation energy, right? They just lower the activation energy. So how do they lower the activation energy? So when the substrate binds to active site of the enzyme, temporary bonds are formed. So there is slight rearrangement in the bonds that brings the substrate into transition state, which favors its easy conversion into products, right? So in this way, enzymes lower the activation energy. And at the end of the reaction, they themselves remain unchanged. They themselves remain unaltered. However, the substrate is converted into product. However, the substrate is converted into product. So this was the mechanism of enzyme action. Now, after this, we are going to discuss about nomenclature and classification of enzymes. Section for your level. Now, nomenclature and classification of enzymes. Nomenclature and classification of enzymes. In the past, enzymes were variously named. Enzymes were variously named, giving no idea, giving no idea of their mechanism of action. Mechanism of action. For example, you might have heard the word pepsin, trypsin. These are protein digesting enzymes. So in the past, enzymes were variously named, giving no idea about the mechanism of action of the enzyme or the nature of enzyme, right? For example, we have heard the name pepsin, trypsin. What does pepsin mean? What does trypsin mean? They don't mean anything. They are just arbitrary names. These names are known as arbitrary names. They are arbitrary names, right? So most of the enzymes were named like this, as per the will of the discoverer, right? So pepsin, trypsin, these names didn't indicate anything about the mechanism of action or about the nature of enzymes, right? Some enzymes were named according to their action. Some enzymes were named according to their action. For example, or their source. Some enzymes were named according to their substrate, for example. For example, amylase. This amylase was given the name amylase because of its substrate. It acts on amylose of starch. So amylase, it acts on amylose of starch. That is why it was given the name amylase. Similarly, protease. This protease name, it indicates that it acts on protein. Similarly, lipases. They were named because they act on lipids. These enzymes act on lipids. Nucleases, they acted on nucleic acids, right? So some of the enzymes were named on the basis of their substrate. Amylase, it works on amylose of starch, that is why it was known as amylase. Protease, it works on proteins, that is why it is known as protease. Lipase acts on lipids, that is why it was given the name lipase, right? Some enzymes, they were named after their source. Some enzymes were named according to their source, where from they were obtained. For example, enzymes who were named after their source. For example, bromelain. Bromelain. It was obtained from papaya. Sorry, it was obtained from pineapple. It was obtained from pineapple. Pineapple belongs to family Bromelaceae. So bromelain enzyme, it was named bromelain because it was obtained from pineapple, and pineapple belongs to family Bromelaceae. So on the basis of the source, family Bromelaceae, it was named as bromelain. Similarly, papain. Papain is an enzyme which is obtained from papaya. So some enzymes were named after their source, right? Some enzymes were named according to their action. Some enzymes were named according to their action. For example, polymerase enzymes. Polymerase. We have DNA polymerase, RNA polymerase, right? So these enzymes, they indicated their action. So these enzymes indicate their action. These names, they indicate that these enzymes are involved in combining monomers to form polymers, right? So in this way, enzymes were named variously in the past. Some were named, some were given arbitrary names. For example, trypsin, pepsin. They didn't indicate anything about the action of the enzyme or about the nature of the enzyme. Some enzymes were then named according to their source. For example, bromelain from pineapple Bromelaceae family, papain from papaya fruit, right? Some enzymes were named according to their substrate. For example, amylase working on amylose of starch, protease working on proteins, lipases working on lipids, nucleases working on nucleic acids. Some enzymes were named according to their action. Polymerases, DNA polymerase and RNA polymerase. They indicated that these polymerase enzymes, they joined monomers to form long polymers, right? So there were no hard and fast rules for naming of enzymes. So this created a confusion in the scientific community. This created a confusion in the scientific community because some names, they didn't indicate anything about the nature of enzyme, about the origin of enzyme. So for this purpose, to bring about uniformity in the nomenclature of enzymes. Now enzymes are nowadays named according to ICEN, International Code of Enzyme Nomenclature. Arbitrary names, they had created a lot of confusion in the scientific community. So to set this in order, nowadays enzymes, they are named according to ICEN, International Code of Enzyme Nomenclature. ICEN, International Code of Enzyme Nomenclature. Nomenclature. Formulated by formulated by IUBMB, International Union of Biochemistry, Biochemistry and Molecular Biology and Molecular Biology. So arbitrary names, they had created a lot of confusion in the scientific community because there were some names which didn't indicate anything about the action of enzyme, about the source of enzyme, about the name of the enzyme, or about the nature of enzyme. So for that purpose, International Union of Biochemistry and Molecular Biology, they formulated International Code of Enzyme Nomenclature. And nowadays, every enzyme which is now being discovered is named according to this International Code of Enzyme Nomenclature. What about those names which had got very famous? For example, we still write pepsin, trypsin. So those arbitrary names like pepsin, trypsin, which have become very famous world over, their names have been kept as such. So old names, they have not been changed. They have been retained. However, any newly found enzyme will be named according to this International Code of Enzyme Nomenclature. And old names, which have become very famous world over, they will not be changed because that is likely to create confusion again, right? If we replace the name of pepsin with some new name, if we replace the name of trypsin with some new name, that is definitely going to create very much confusion in the scientific community, right? So those old arbitrary names, they have been retained as such. However, any enzyme which is newly found, that newly found enzyme will be now named according to this International Code of Enzyme Nomenclature formulated by International Union of Biochemistry and Molecular Biology. Okay. So now how the enzymes are named according to this International Code of Enzyme Nomenclature. Now, a newly found enzyme will be named according to this ICEN. So according to the guidelines of ICEN, according to the guidelines of ICEN, International Code of Enzyme Nomenclature, the name of every enzyme should end. Name of an enzyme should end with with a suffix "ase". So according to International Code of Enzyme Nomenclature, any newly found enzyme, any newly found enzyme's name should end with the suffix "ase". What does "ase" mean? "Ase" indicates an enzyme. "Ase" indicates an enzyme. So first of all, the name of enzyme, it should end. It should end with the suffix "ase". "Ase" means an enzyme. Then the name of enzyme. Name of enzyme should have two parts. Should have two parts. The name of enzyme must be divided into two parts. First part of the name. First part of the name should indicate the substrate of the enzyme. The substrate of the enzyme. And second part of the name, second part of the name should indicate reaction catalyzed, reaction catalyzed by the enzyme. So according to ICA, the name of an enzyme should end with the suffix "ase". "Ase" means an enzyme. Then the name should be divided into two parts. First part of the name, first part of the name should indicate the substrate of the enzyme. First part of the name should indicate the substrate of the enzyme, substrates or substrate of the enzyme. Second part of the name should indicate, it should indicate reaction catalyzed. What reaction is catalyzed by this enzyme, right? So according to ICEN, now the name of enzyme should clearly indicate what are its substrates or what is it a substrate and what type of reaction does it catalyze, right? And the name should end with the suffix "ase", and this "ase" represents an enzyme. So we are not supposed to write lipase enzyme, because when we write lipase, it has got ASE at the end. So it indicates that this lipase is an enzyme. So we are not required to write lipase enzyme, right? So this is the guideline of the ICEN, International Code of Enzyme Nomenclature. So according to this International Code of Enzyme Nomenclature, the name of an enzyme should end with the suffix "ase". Then the name should be divided into two parts. First part of the name should indicate the substrate or the substrates. Second part of the name should indicate reaction catalyzed by the enzyme. For example, I think we are running out of time, so we will discuss the remaining part of it tomorrow, inshallah. How many of you are present? Okay. So thank you for being in my class. I am ending the meeting. Again, I forgot to record this.